This is part 8 of our series of lectures on section 1.6, and in this lecture we're going to consider this limit statement, and we're going to see if we can write a formal proof of it. So the first step, as usual, is to write it in symbols. So in order to do that, you'll have to recall what is the working definition of the limit of some expression equaling some number. So recall that for yourself, put your video on pause, and see if you can write this in symbols. Here's the formal working definition of the above limit statement. It says that for every positive real number epsilon, there exists a positive real number delta, such that for every real number x, if the absolute value of x minus 3 lies between 0 and delta, then the absolute value of our function 5x plus 1 over 3x minus 1 minus 2 is less than epsilon. So how do we write a proof of this? The first step is easy. You'd start by saying let epsilon be a given positive real number, and then the hard step is to figure out how to choose this delta so that the rest of this statement is true. So let's do a calculation. We're going to calculate this quantity here and see what it's going to take, what condition on delta it's going to take, so that the moment absolute x minus 3 is smaller than that delta, then we can actually deduce that this is smaller than epsilon. So let's begin by calculating 5x plus 1 over 3x minus 1 minus 2 and see what it gives us. It's absolute 5x plus 1 divided by 3x minus 1 minus 2. If you calculate that, you'll see it comes out to be minus x plus 3 divided by 3x minus 1, which, since it's an absolute value, that's the same as absolute x minus 3 divided by absolute 3x minus 1. Now we're going to be assuming that absolute x minus 3 is smaller than delta, so I can use that as an upper bound for my numerator. That's smaller than delta divided by absolute 3x minus 1. Now I want to somehow show that this is smaller than epsilon, so somehow I have to make this smaller than something. So in order to make this smaller than something, do I need to replace absolute 3x minus 1 by something bigger than it or something smaller than it? Well, if I divide delta by something bigger than this, I don't get something bigger, I get something smaller. So I actually have to replace this quantity by something smaller than it, not something bigger than it. So in other words, I need a positive lower bound on absolute 3x minus 1. So that's what I do next. I need a lower bound on absolute 3x minus 1. And I taught you something about finding lower bounds on things a few videos ago. And since we're interested in seeing things of the form absolute x minus 3 showing up, what I do is I try to get x minus 3's in the picture by adding and subtracting a 3 minus 1. And that's equal to 3 times x minus 3. 9 minus 1 is 8. And now I apply reverse triangle inequality to get 8 minus 3 times absolute x minus 3. That's the reverse triangle inequality. And now, now I know that absolute x minus 3 is smaller than delta. So if I knew also that delta was smaller than 1, okay, so I say it's desirable, I want delta to be less than or equal to 1, because if I have delta less than or equal to 1, when I say that this is smaller than delta, and delta is smaller than or equal to 1, then this is less than or equal to 1, so minus it is bigger than or equal to minus 1. So that would mean I could write this as being bigger than or equal to 8 minus 3 times 1, which is 5. So there you see I get my lower bound of 5 on this 3x minus 1, just with the assumption that delta is less than or equal to 1. And once I have that lower bound, I can now go back here and say that this is less than delta divided by 5, or less than or equal to delta divided by 5, because since absolute 3x minus 1 is bigger than 5, 1 over absolute 3x minus 1 is smaller than 1 over 5. And now finally, I can ask for this to be less than or equal to epsilon. So I want that to be the case, and that will be the case provided delta is less than or equal to 5 epsilon. So I want delta to be less than or equal to 5 epsilon. And if it is, then I get this last inequality, and then I'm finished, because now I've proven what I'm interested in proving, that this 5x plus 1 over 3x minus 1 minus 2 is smaller than epsilon through this string of inequalities. So everything will work provided delta is a positive number satisfying this condition and this condition. And the simplest way I can think of achieving that is to just simply choose delta to be the minimum of those two numbers. Take it to be the minimum of the number 1 and 5 epsilon. Okay, so if I do that, I'll have a positive real number. It will satisfy this condition, and it will also satisfy this condition, and therefore I can make the argument work. And with that, I think we're ready to finish the proof, because this tells you how to write the second sentence of the proof. The second sentence of the proof should be just simply choose delta to, choose delta to be the minimum of 1 and 5 epsilon. Now, how are we going to get the balance of the proof to work? What is the order of things that you should do? You begin by giving yourself an epsilon. You then choose your delta in this way. Then you give yourself a real number x. And then you assume that this happens. And now you have to prove that this happens. And how do you do that? Well, I think you really have to first argue how to get your lower bound. So the next step, I think, would be to start with this expression and explain how you're getting your lower bound of 5. And after you finish that, you can go directly here and give this string of inequalities to show that it's smaller than epsilon. Okay, so that's the idea of the proof. So why don't you put your video on pause and see if you can write down the proof. And when you come back, you can have a look at my proof. Here's my proof, and as I read the proof, follow along the symbolic form of the proposition to make sure that I'm writing the appropriate sentences corresponding to what's written in the symbols. So the first sentence should be something like, let epsilon be a given positive real number. And next we have to choose our delta in some special way, and remember we decided we would choose it in this way. And I claim that we should be able to make the rest of the proof work. Next, we say let x be a real number, and then suppose our hypothesis is true. So that's this one here. And now I have to prove that this happens. And my suggestion to you was to begin by showing how you can get a positive lower bound on absolute 3x minus 1. And so I'm warning you that that's what I'm about to do, and so I write it in this way. So I write down my absolute 3x minus 1 equals, I do the little trick of adding and subtracting 3. The 3's here, by the way, have nothing to do with this coefficient. It has to do with the fact that we're taking the limit as x goes to 3. So minus 3 plus 3, that simplifies to this. Now I apply reverse triangle inequality to get this. And now, since I've assumed that delta is smaller than or equal to 1, and we know that x minus 8 is smaller than delta, which is in turn smaller than 1, then minus it is bigger than minus 1, and so we get this. which is 5. So there's my lower bound on this, and thus, now I'm ready to do this calculation. I'm going to prove that it's smaller than epsilon. I combine. The numerator is smaller than delta, and my lower bound gives me that I can replace that by 5. And this is smaller than epsilon, since delta is also smaller than or equal to 5 epsilon. And that completes the proof.